The final lesson of the week, 8-6, the sine and cosine ratios. They're taking these two together. So if you recall yesterday or whatever day you did it, we did the tangent one. So remember that the tangent of an angle, so sometimes they call it theta, you could call it x, is the opposite over the adjacent. There's nothing to do with the hypotenuse. Today we're going to learn two that have to do with the hypotenuse. Now let's recall we have SOHCAHTOA. SOHCAHTOA. When I was in school, I just memorized sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, but the new teachers do that. So we're going to talk about sine and cosine today. So if we have sine of an angle, I'm going to use theta for my angle. It's opposite over the hypotenuse. The cosine of an angle, this is what this is all saying over here, is the adjacent side to the angle over the hypotenuse. So that's basically what they're saying. They're pointing out all the parts. So if you're finding the sine of A, so here is A, it's the opposite, it's right opposite over the hypotenuse. If you're finding the cosine of the same angle, it's going to be the adjacent over the hypotenuse. So now we have three, like what they said. Right down here, we have our three. So we have tangent is opposite over adjacent, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, or SOHCAHTOA. Sine OH, cos C-A-H, and T-A-H, TOA, SOHCA. All right, let's try some examples. Find the values of x and y to the nearest integer. So they only give us one angle. Of course, we could figure out this one. We could take 180 and subtract 90 and 67 and work with this angle. But we're going to work with the angle that they give us. We want to find the sides. Now, let's see. I think there's going to be two ways we can do this. So let me get the black pen. Okay, so if we find the sine of 67, its opposite, which is going to be x, over 120. So let's try that one. So sine of x equals the opposite, sine of 67. Sine of 67 equals the opposite over the hypotenuse. So you would have to use your calculator, just like what we did with the tangent function. You would put in your calculator sine 67, and that's going to be, you can work right along with me, is 0.92 approximately, equals x over 120. Multiply that by 120, just leave it in your calculator, and you get x equals 110.46. Of course, that's approximate again, so that's your x. If you want to get y, we'll use cosine, because we need this adjacent one. So we would say the cosine of 67 equals y over 120. So we're going to do the exact same thing. We're going to put cosine 67 in our calculator, and I got 0.3907311285, and I'm going to take that times 120. I'm just out of room. So we get y equals approximately 46.89. So you can see that's a smaller side. Make sure that your answers make sense. And that is how you use sine and cosine to find missing sides. Now we're going to talk about missing angles. I can't move that up any. All right, so here we have n, and we want to find what degree it is to the nearest integer. This is the nearest integer too. I should follow the directions. So this one should be x is approximately 110, and here y is equal to approximately 47. Okay, nearest integer. Now, we have the hypotenuse, right? So we're going to use sine or cosine instead of using tangent. Tangent would be good if we had these two. So we have the opposite. So the one that's the opposite is the sine. So remember this so, ka, toa. So sine is the opposite, and that's this one. So we would say sine of n equals opposite over hypotenuse. So we would say n equals the inverse. Remember, when you're finding the angle, you use the inverse of 22 over 40. This is 40. 22 over 40. You don't need to reduce that either. You can just say sine of 22 divided by 40. And we're going to get, oops, I forgot to do the inverse. Inverse sine of 22 divided by 40 is 33.367 degrees. So they want the nearest degree, so it's going to be 33 degrees. Isn't that fun? Okay, there's one more example, and then we'll look at the practice problems. So this one says an isosceles triangle has sides 8, 8, and 6. Find the lengths of its 3 altitudes. Yikes. Okay. Let's go with this first altitude, I would guess. So this is an isosceles triangle, so we drew this line down here, and we have to figure out what the other angles are. So we have to use the Pythagorean theorem in order to get this altitude. Little piece of work here. So Pythagorean theorem says 3 squared, these are the legs, plus x squared equals the hypotenuse squared. So we're going to get 9 plus x squared equals 64. And we're going to get x squared equals 64 minus 9. So we're going to get 55. So x is going to equal the square root of 55. Now we have some things to deal with. Oh, well, it doesn't ask us to find... Yeah, so we know what x is now. And that's all they ask for. So you can just leave it the square root of 55, or you can just put it in your calculator. All right, let's look at this altitude down here. So this one down here, we want to find this altitude. So my refrigerator's beeping and it's driving me crazy, guys, so I don't want to stop, but here we go. Okay, so this triangle, we know this is a 45-degree angle right here. So we can use opposite over hypotenuse to get y. So we would say sine of 68 degrees equals the opposite, which is y, over the hypotenuse, which is 6. So we put sine of 68 in my calculator, in your calculator, someone's calculator. So we get 0.927 equals y over 6, and we cross multiply. And we're going to get y is approximately equal to 5.56. They wanted 3 altitudes, but they're only showing us doing 2 here, so we're just going to leave it at that. So that is the other altitude, which is y. All right, let's look at a couple practice problems. So in exercises 1 through 3, express sine, cosine, tangent as fractions. So they want us to do sine of a, cosine of a, and tangent of a. So here we go. Let's just do these really quick. These are kind of easy. So sine of a would be opposite over hypotenuse. So sine of a would be 8/17. Cosine of a would be adjacent, which would be 15 over hypotenuse, would be 17. And tangent of a would be opposite, which would be 8 over adjacent, which would be 15, so it would be 8/15. So those are all pretty much similar. If you get down to this one with just variables, you would just name them as variable fractions. Like the sine of a would be a over c. the cosine would be, whoops, yeah, the cosine would be adjacent, so it would be b over hypotenuse is c, and the tangent is going to be opposite, which is a, over adjacent, which is b. So using the triangles in exercises 1 through 3 express sine b, cosine b, tangent b. So you just do the same thing, only you would start with this angle. So sine of b would be 15 over 17. Cosine of b would be 8 over 17, and the tangent would be 15 over 8. Now this part where they say, you just put this in your calculator, sine of 24, write your answer, cosine of 57. Where they have the angle, you would do the inverse cosine of this. The inverse sine of this, inverse cosine of this would give you the angles. So here it says state 2 different equations you could use to find the value of x. So we are given the hypotenuse, right? And we're given these 2 angles. So let's just do one of these real quick. So we could say the sine of 41, you don't have to solve these, equals the opposite over the hypotenuse. Or we could say the cosine of 49, see here's 49, is adjacent over hypotenuse. So these problems will be as hard or as easy as you remember Algebra 1, unfortunately. So let's see if I have one more slide to do on this. Yep, I do. Let's see if this is worth doing. It says, okay, we're not going to do that one. Suppose the sine of n is 5 over 13. Find the cosine of n and tangent of n without using a table or a calculator. So what they're basically doing is they're just having us, we know this is a 5, 12, 13 triangle, right? So we can put 12 in there. And we're going to, without a table or without a calculator, can we find that degree? I don't really know how to do that one. So we're just going to leave it at that. I mean, we could find out, we could say the sine of n is going to be opposite over hypotenuse. So I'm not exactly sure how they want you to do that without a table. If you could use your calculator, you would say the inverse sine of 5 over 13. So we'll just go with that. So anyway, you're going to have some homework problems, and you have to figure out whether to use sine, cosine, or tangent. They can be a little difficult. Let's do one of the difficult ones, and then we'll end this lesson. Let's see if I can move this over. One sec, guys. It's not letting me move this time. I'm having trouble finding a place to write. All right, so we'll just do below. So maybe an example of a more difficult one would be number, none of them look that difficult, except you're going to have to use the Pythagorean theorem on some of these. Let's just do number 10 real quick. So number 10 would be, it's a triangle that looks like this. There we go. Whoops. And whoa, that was bad drawing. So we have 6, this is 12, this is 12, and they're telling us that this distance here is 16. So that means this has to be 8 and this has to be 8 because it's an isosceles and it's bisected it. And then this is a y degrees. And we need to find out what x is. So we don't have any of the, I told you this one's a little bit harder. So we're going to go with this side right here. We don't have the angle. We know it's a isosceles triangle. So we're going to have to get this y degrees first. So we're going to say, what do we have here? We have the hypotenuse, we have the opposite. So we would say the sine of y equals the opposite which would be 8 over 12. So we would do the inverse sine of 8 over 12. You don't need to reduce it unless it really makes you happy to do that. So we're going to do the inverse sine. Sorry, my calculator's battery is going dead now. Of 8 over 12. And so we're going to get this angle, y is going to equal 41.8 degrees. So we have that. We know that this side also has to be 41.8. And now we can get what this side is right here. It's the adjacent side. So we would say the cosine of 41.8 equals adjacent over hypotenuse, which is 12. So we're going to do the cosine of that number. So on your calculator you could say cosine of the answer and then take it times 12, and we're going to get that side is 8.94. All right, that one was a little tricky. So I expect questions from all of these lessons because they are a little more difficult, especially for those that don't remember Algebra 2 or never had it. So that is it for lesson 8.6. And then next week I'll do 8.7 for you as well. All right.